Okay. Let me give you another example of a matrix. Let's say that in the plane, we look at the transformation that does rotation by 90 degrees. Let's say counterclockwise. So I claim that this is given by the matrix 0, 1, minus 1, 0. So let's try to see why that is the case. Well, if I do r times I hat, so if I apply that to the first vector, I hat, so that means, okay, I hat will be 1, 0. This product, well, here you will get 0, and then you will get 1. You get j hat. Okay, so this thing sends I hat to j hat. What about j hat? Well, you get negative 1, and then you get 0. So that's minus I hat. So j is sent towards here. And in general, if you apply it to a vector with coordinates xy, with components xy, then you will get back minus yx, which is the formula we've seen for rotating a vector by 90 degrees. So it seems to do what we want. By the way, I should point out, so the columns in this matrix represent what happens to each basis vector, to the vectors I and j. See, this guy here is exactly what we get when we multiply r by I. And when we multiply r by j, we get this guy here. So what's interesting about this matrix? Well, we can do computations with matrices in ways that are easier than writing coordinate change formulas. For example, if you compute r squared, so if you multiply r with itself, well, I let you do it as an exercise, but you will find that you get minus 1, minus 1, 0, 0. So that's minus the identity matrix. Why is that? Well, if I rotate something by 90 degrees, and then I rotate by 90 degrees again, then I will rotate by 180 degrees. That means I will actually just go to the opposite point around the origin. So I will take xy to minus x minus y. Okay? And if I applied r 4 times, r to the 4 would be identity. Okay, questions? Yes?
When you came up for r equals that matrix, is that like the definition of r, or is that just?
That's a very good question. So how did I come up with this r? Well, secretly, I worked pretty hard to find what are the entries that would tell me how to rotate something by 90 degrees counterclockwise. So remember, I should have said, what we saw, I think, last time or in the first lecture, is that to rotate a vector by 90 degrees, we should change xy to minus yx. Okay? And so now I'm trying to express this transformation as a matrix. And if you work out, how these guys, so maybe you want to call these guys u and v, and if you write u equals 0x minus 1y, 0x minus 1y, and then v equals 1x plus 0y, 1x plus 0y. Okay, so that's how I would find it. Here, actually, I just gave it to you, ready-made. So you didn't really see how I found it. But, you will see more about rotations on the problem set. So you're going to see more about these things.